Different physical quantities are measured using different measuring scale. The mass of solid substances are measured in kg or gram scale. Mass of liquids are measured by their volume in liter or milliliter scale. Besides mass, some items can also be counted in pair or in dozen. But atoms, we all know that substances are made up of atoms, the tiny particles. Still, we can weigh the mass of an atom. The mass of an atom is the mass of its nucleons. The electrons having negligible mass, the mass of electron is ignored. The total mass of protons and neutrons comprise the mass of an atom. There are some specific methods of measurement of the atomic weight, atomic mass, and molar mass. IUPAC recommended the carbon 12 scale for measuring all these quantities of atom. A carbon atom is 12 times heavier than the lightest hydrogen atoms. So the relative weight of a carbon atom in respect of the lightest hydrogen atom is 12. The relative weight of an atom is called its atomic weight. Atomic weight is only a number. It has no unit because it is the ratio of two weights. So the atomic weight of carbon is 12. But atomic weight does not give us the mass of an atom. When atomic weight is expressed in gram unit, it represents the atomic mass and it is named 1 gram atom. Therefore, we simply write G with the atomic weight for the atomic mass of carbon atom, that is 12 gram, and it is named 1 gram atom of carbon. So 1 gram atom of carbon is 12 gram of carbon. But wait, is 12 gram is the mass of one carbon atom? Absolutely not. An atom is such a tiny particle that we cannot see it or cannot touch it. So it is quite difficult to measure a single atom. But scientist Sir Avocado solved this problem. Sir Avocado proved that 1 gram of any element or compound holds 6.023 into 10 raised to the power 23 particles. Particles means either atom, molecules, or ions. So the mass of substance, which is constituted by this number of particles, that mass of substance can easily be handled. The number 6.023 into 10 raised to the power 23, this number is called Avogadro number with its unit name mole. The mass of substance which is constituted by this number of particles means this number of atoms or molecules or ions is called 1 gram. 1 gram of any element or compound. Mole. Mole is a unit. Mole gives us a definite quantity in number. So 1 mole is 6.023 into 10 raised to the power 23 particle. What does it mean? When we say a pair of roses, it means 2 roses. When we say a dozen of apples, it means 12 apples. When we say a scores of book, it means 20 books. And when we say 1 mole of particles, it means 6.023 into 10 raised to the power 23 particles. And particles may be molecule or atoms or ions. So mole is a certain quantity of an element or compound which holds 6.023 into 10 raised to the power 23 constituent particles. 1 gram carbon is constituted by 6.023 into 10 raised to the power 23 atoms. And we know that the weight of 1 gram carbon is 12 gram. So we can say that 6.023 into 10 raised to the power 23 carbon atoms. The weight of this number of carbon atoms is 12 gram. So to get the actual mass of one carbon atom, we simply have to divide the 12 gram by 6.023 into 10 raised to the power 23. So the mass of one carbon atom is 12 upon 6.023 into 10 raised to the power 23 gram. But IUPAC says that for carbon scale, 1/12 of the actual mass of one carbon atom is needed. But why? Why 1/12 of the actual mass of one carbon atom is taken? Because we know that 1/12 of a carbon atom equals one hydrogen atom. So for carbon scale, to get a 1/12 of the actual mass of one carbon atom, we simply have to divide the actual mass of one carbon atom by 12. And by calculation, the value is coming 1.6603 into 10 raised to the power minus 24 gram. And this is the standard unit value of the carbon scale with the unit name AMU. So 1 AMU with its value 1.6603 into 10 raised to the power minus 24 gram is the standard scale for measuring atomic mass. So the carbon has atomic weight 12, atomic mass 12 AMU, and gram atomic mass 12 gram. Using this carbon scale, all other elements and compounds can easily be measured. The atomic weight of oxygen is that as it is heavier than the 1/12 of a carbon atom. This way, the atomic weight of oxygen is 16 because it is 16 times heavier than the 1/12 of carbon atom. With the unit AMU, atomic mass of oxygen is 16 AMU. Or replacing the AMU with its unit value, the atomic mass of an oxygen atom is 16 into 1.6603 into 10 raised to the power minus 24 gram or 16 AMU. And the gram atomic mass is 16 gram. Same way, nitrogen is 14 times heavier than the 1/12 of a carbon atom. So the atomic weight of nitrogen is 14 and atomic mass is 14 into 1.6603 into 10 raised to the power minus 24 gram or 14 AMU. And the gram atomic mass of nitrogen is 14 gram. Same way, chlorine has atomic weight 35, atomic mass 35 AMU, and gram atomic mass 35 gram. For molecular weight, the atomic weight is to be multiplied with the atomicity of the respective elements. We know that oxygen, nitrogen, and chlorine, the molecules of all these elements are diatomic. So their atomicity is 2. So multiplying the atomic weight of oxygen by 2, we get the molecular weight 32. And expressing the molecular weight in gram unit, we get the molecular mass 32 gram. Same way, when the atomic weight of nitrogen will be multiplied by the atomicity, that is 2, we get the molecular weight 28 and the gram molecular mass 28 gram. And the atomicity of a chlorine molecule, that is 2, when multiplied to its atomic weight, we get the molecular weight 70 with gram molecular mass 70 gram. Let me say you how 1 gram atomic or 1 gram molecular mass is related to moles. 1 gram atom of any element holds 6.023 into 10 raised to the power 23 atoms. The mass of elements which hold this number of atoms is called 1 mole. Same way, when we talk about 1 gram molecule or 1 gram molecular mass, then 6.023 10 to the power 23 molecules are present in 1 gram molecule or 1 gram molecular mass, which is also called 1 mole. So 1 gram molecular mass of any elemental compound equates to 1 mole. Using this formula, we can derive either the number of moles or the molecular mass of any elemental compound. We can easily derive number of moles from a given mass. If the mass of oxygen is given 128 gram, then by simply dividing the given mass by its molecular mass, that is 32 gram, we get the number of moles, that is 4. Same way, when 84 gram of nitrogen will be divided by its molecular mass 28 gram, then we can say we are given 3 moles of nitrogen. When 175 gram of chlorine will be divided by its gram molecular mass 70 gram, then we can say that 2.5 moles of chlorine is present in 170 gram of chlorine. So this way, from given mass, we can easily derive the number of moles. By reverse calculation from given moles, we can get the given mass. This time, the number of moles is to be multiplied by the gram atomic mass. So if 4 moles of oxygen is given, so multiplying 4 moles with the gram atomic mass, that is 16 gram, we can get the given atomic mass, that is 64 gram. Same way, when 3 moles of nitrogen is given, then multiplying the 3 moles of nitrogen by its gram atomic mass, that is 14 gram, we can get the given atomic mass, that is 42 gram. Same way, in given 2.5 moles of chlorine, 87.5 gram of atomic mass is present. This conversion from atomic or molecular mass to moles and vice versa helps us to decide the weight of reactants and products in chemical reaction